Polish, please.
Nazywam się Hemel. I ja lubię App Engine. App Engine? I don't know how to pronounce this badly. Okay. So what's Google App Engine? This is, I actually need to check Wikipedia, it's quite old. It launched in April 2008. And that's 8 years ago. This is me, 2008. I mean, I was still living in Holland, living like the Dutch do, in my orange shirt, like hanging out with fries and this kind of stuff. So, I mean, we have to kind of imagine like this kind of time. This is a different time in my life. What?
Is it possible? To imagine.
To imagine, yeah, you know, you don't come to in Holland very often, clearly. Like, this is what we do. We wear poor clothing and hang out with fries. So, also I was really getting excited about the cloud, as you can tell. This is my kite, I got it for my birthday. In 2008. Okay, so Google App Engine, anyway, launched in 2008, so that's a while back, different time. Probably if you're a true historian, this statement isn't true. It's probably not the first platform as a service, but so soon I'm going to claim it's the first platform as a service. So, I mean, now you have Roku, you have all these kinds of different things, then that was quite a new thing. So that was interesting. And presumably this was a platform to build Google scale applications. And like, oh my, why wouldn't you want to do that, right? Everybody wants to go Google scale. And Python.
Tomek from Wrocław is asking if they can ask by Zurich. Via Zurich.
Aha, okay.
So I will answer. Tomek, please write to me. I mean Tomasz Woźniak. So
Tomasz Wodrzyński.
Okay, so you should know. Okay, let's continue.
Okay, so and it's Python. It launched with just Python 2.5. By now you can use Java, PHP, Go, Node, even like random stuff. But I mean, I'm talking about 2008. And so basically what it allows you to do is run your Python application on the Google infrastructure, and then it gives you a whole bunch of APIs with interesting stuff that you may need. There's a data store, which I'll talk about in a little bit. There's a blob store, which is to store big files, right? There's a channel API, which is basically pushing data from the server to the client, like WebSockets, before there were WebSockets. Memcache, you know, you can do all kinds of image transformations fairly easily. There's logging inbuilt in. You can do URL fetching. You have full text search in there. There's receiving and sending email. Scheduling of tasks, task queues, user service to easily log in using a Google account, for instance. It's trivial. There's Java support. Very exciting. And you can fairly easily build multi-tenant systems where you can create, like, basically deploy exactly the same code base from different users in a fairly easy way. And by now you can also access like MySQL, Google Cloud SQL, but we're going to ignore that. And what you get in return also is you get a bunch of restrictions. I seem to remember when it launched, there was a time limit of a request which was 2 seconds. Now it's a minute, so it's a lot easier, let's say. 2 seconds is more challenging, so that was more fun actually. There's no local store, well there is, but you cannot access, you cannot write anything to disk. I mean, you could store stuff in memory, because your instances can be killed after a few minutes, you probably shouldn't. And it's really pushing you in a different way of thinking that I was used to in 2008 anymore, anyway. And you pay by instance hour, so however long your application is running, charged by minute, I think, I'm not sure. Well, charged by hour, but they counted by minute. You pay for data store operations, so if you do a read on a database, you pay for that, and you write, you pay for that. Basically per call. And data transfer. Okay, so who cares, right? That's all very interesting. Why do I find this nice? And this is the moment to cue the Apple commercial. It forces you to think differently, right? Like at least in 2008, like this is my reality, right? If you use a database, you use a SQL database. That's all that's there. That's what I learned in university. SQL queries, nice, blah blah blah. So, and the query is basically free. If you do one query, 3 queries, like who cares? Like, yeah, you know that if it gets really big, like, okay, that's a problem, but nobody's really big. I can change my schema anytime. I can add a column, create a table, remove a column. Why not? If you run a web app, you just like get a server somewhere, you boot up your process in the background, and you're done, right? Like one process, like nice and simple. If you upload a file, you just store it temporarily in a temporary directory, and you put a bunch of stuff together. You can zip things, like just use the local storage, or you can keep things in memory, counters in memory, because it's all one process. Why not? And failures are rare. Like your server doesn't crash. Servers don't crash. So here's Google reality. SQL is really hard to scale if you do joins and you use all the kinds of fancy features. I mean, Facebook runs on SQL. They're fairly big, so it does scale. But actually, when you don't use any features, it's basically you should use it as not a SQL database. So the joins are expensive because you may have to join across multiple servers because your database no longer fits on a single server. Constraints, similar issue. If you want to have a uniqueness constraint on a column, but you have 1,000 database servers, how are you going to check that? Right? It becomes very, very hard. And schema changes, like we find this even in some of our projects, they have tables with so many millions of rows that if you want to add a column, you have to shut down the system for hours, so you can't, basically. So you have to handle that in a different way. Web apps, tens of thousands of processes, right? Google doesn't operate on one server. Like if you run something on a server, it doesn't exist, basically. It will go down, like servers crash all the time. And basically, because you are distributed, so widely distributed, you cannot keep state on any node. If you have data on one node, it also doesn't exist because it can go at any minute. And failures happen all the time, right? I think I don't remember what the failure rate of Google servers is, but it's like every minute servers are failing, right? In that Google scale. So this is quite different, and whether we actually face this ourselves doesn't matter. Google App Engine kind of forces us in that kind of mindset, right? They don't allow anything that could possibly go wrong. So I want to focus on two parts of that. So the first is the SQL one, which is actually the Datastore one. So the App Engine Datastore, there's no fixed schema. There are no integrity constraints. You cannot do any joins. I mean, you can always do joins by just querying a lot, basically, but in principle, there's no like, proper joins. And you can only do queries on indexes. You cannot do like happy-go-lucky random queries at all, because it won't scale. So what does it mean? So I'm going to use this very classic example of Stack Overflow. Don't read the question, actually I don't know what it is. It's a JavaScript question. So how do you model this kind of system, right? A question and answer system. So let's focus on the answers. So what you would probably do if you want to build a database schema for this, you would have an answer entity, right, with an ID, a question ID, because an answer belongs to a question, a title, title actually not really, that's old. Author ID, foreign key, whether the answer was accepted or not, the text of the answer, the creation date, the edited date. But then, basically what you have to do to run on this page, you query this answer table, except that's not enough information because you have to have the full name of the user, you want to get the point, the number of points and this kind of stuff, all the information that's here, so you have to do a left join with the user table. Also, you have these comments here. So I don't know how you want to do that. Maybe you do a query per answer, or you batch up all the answer IDs and do one query to fetch all the comments. And then the common one you have to join with the user table. Then you have votes, those point numbers, so you probably have to do some kind of aggregate query on those to be able to insert those here. You probably also need a vote table for the comments. So, I mean, quite quickly, and I think Stack Overflow actually is using SQL Server, so it's actually using SQL. I don't know if they do this level of normalization, but quite quickly you have to do a lot of joins, right? Pulling data from all different sites to render a view. And on a small scale, that's fine. On a big scale, and especially in Google App Engine, you cannot do this. What you can do is query over the answer table and then fetch a user for every little entry, but that gets really expensive, of course. So typically, this is more where you're aiming towards. If you do stuff on App Engine, you start to denormalize, you start to copy stuff in the place where you need it, right? So you start to optimize your database schema for reads. And if you do this, so this is a fairly extreme example. So we inline the author name here, so that's fairly not that problematic. It's only problematic if people change their names all the time, because then you would have to like scan all the answers and update the names. Points, I mean, probably you'll do this anyway because you don't want to like aggregate the vote count every time. But this, I don't know, I don't know if people actually do this, but you could imagine like even inlining the top comments, because all those answers only list the 5 top comments. So why not just get all that data, dump it to a JSON, inject it into the entry, because all answers always show those comments. And if you click on the show 21 more comments, you can just fetch the rest, right? But for the first view, this is enough. So basically all you have to do now is just do a single query on the answer table and everything is there except maybe points, which you may have to fetch in some other way, like lazily or something. And so basically you're really forced to think about like, how am I going to query this data and not like make it up as you go, basically. And also pay the cost in writes, because when somebody's voting on a comment, you probably have to like rewrite this thing. If somebody's adding a comment, you also have to update the comments, but you also have to update the answer. If somebody's changing his name, you have to change this stuff all over the place. So you really have a big trade-off between where do you copy this data and when is it going to bite you in the ass, basically. But this is interesting, right? So that's why I like it. So this is how you query such a table. I mean, this is like a nice layer on top, right? So answer that query. Well, I want to find all the answers that are an answer to this question. Order in reverse order. This is how you write that based on points. And I fetched 20. So as I said, you can only query stuff that's actually indexed. And by default, every column separately is indexed. So you can always query based on one value. But if you want to combine 2, and actually you're combining 2, because you are filtering on this and you're sorting by that, you have to explicitly create an index. And then in your project, you have this index.yaml file, and you can define, okay, for my answer kind, not table, but kind, I want to index based on question ID, on points, and even you have to specify the direction, because it's going to pre-order all that stuff. And then you basically submit this to Google, and they build the index, and everything is fine. So in principle, you can build, I think there's a limit of 200 indexes, extra indexes, so that's quite a lot. So why not just index all the things? Well, this is where this other nice aspect, which is actually the expensive aspect of it, comes in. Google makes its pricing in many ways very more transparent than it's probably is if you use a SQL database. Like if you run a MySQL database, like, do you know what a query costs? Probably not. I can tell you that, I mean, it's not that much, right? Like you pay 6 cents for like 100,000 operations, and fetching one entity is one such an operation. But still, you can somehow, like by making this so transparent, you're like everything you do, you start to think about, so what's that going to cost me? And that also means, like, for instance, writes, if you have like a bunch of indexes, like one write of updating an entity, this costs 1 write plus 4 writes per modified property value plus 2 writes per modified index, right? So if you have 100 indexes, and now all of a sudden you have like 100 writes operations for like saving a single thing, maybe you are like reconsidering how many indexes you really need. So, I mean, in practice, probably like if you're the one paying the bill, this is really annoying. For me, this is kind of interesting because, again, you're trading off different things, right? Like how expensive are my reads versus my writes? Should I index or not? This kind of stuff. All right. Then the other aspect, which is the scaling aspect, and actually. So what I wanted to very briefly talk about, because I'm probably running out of time, but there's a couple of features in here that are generally implemented in a pull way. If you are reading, like fetching emails, you just establish a connection with an IMAP server or something, and you pull, like, do I get? You basically have a persistent connection and you wait for stuff to flow in, right? Those task queues are the same, like if you use Celery or something, you start a process that's listening on a queue, waiting for stuff to come in. And Jabber is kind of similar. You establish a connection to a Jabber server waiting for messages to come in. But then the question is like, okay, so how many processes of those do I start? What if they crash? Do they, like, am I handling the errors well? What, I mean, with tasks, like if I'm in the middle of processing a messaging, crashing, like, is that message going to be processed in the future? If I read an email but then didn't handle it, like, is all that stuff handled correctly? This is kind of tricky to get right. And actually Google, like, in App Engine flipped it around by turning this kind of pull mechanisms into push mechanisms, and all pushing over HTTP. So all those things are actually no longer pull things, but they're push things. And you get a lot of advantages from that. So basically all the same rules applies. I mean, the load balancing happens automatically. You have a clearly defined interface because everybody knows HTTP. And it's also clear whether a request was successful, because if there's like a 200 error code, then it's fine. If it's 500, like, maybe we should try something again. So what you actually see when you look at various parts of the documentation, like this email feature, basically, like if you email to some email address, it will just post on a certain URL. So when I email to blah, blah, blah at my appid.appspotmail.com, I can expect in the near future basically a post request on /AH mail address. So if I listen to that, let's say if I handle that request, then the body will contain the body of the email, and then when I return 200, the email is handled correctly. If I return 500, it probably at some other point in time I'll get this email again. Same story for task queues. So if you are handling a message but you're failing or you're timing out or something, it will just offer it to another process. And also like the Jabber, if you want to build a Jabber bot, which you can apparently do, I really wonder how many users this service has. But basically for every message you get an HTTP post. Actually, I thought the real-time, like the WebSocket thing also worked this way, but it turns out not to work slightly differently. But this idea of like turning pull into push and just handling like the scalability and the reliability that way, I find inspiring. And that's it. So conclusion. Whether you like App Engine or Google or not, whether you like the fact that this is like massively proprietary and you won't ever be able to move your application anywhere because all the APIs are Google specific, which is obviously a big drawback. It's something different, and you'll learn because it's just a different way of thinking about how to scale things and how to organize data. I mean, some people seem to be looking for like the technology of their life. You know, like, hey, like, oh, Django is my life. I only want to do Django. Like, you don't have to marry it. You can, maybe in some countries, and maybe Google will hire you. But probably not. And that's it.
Okay, I have one question.
Okay.
Is there any traceback tracking system, or are you supposed to organize my own, like New Relic or Sentry?
There's a logging. I mean, there's logging built in, so that's one thing. For the rest, I don't know actually. What's there in terms of? I mean, Sentry is mostly logs, right? Or I don't know. That's only what I've seen. What?
For tracebacks.
Tracebacks, yeah. I mean, the logs. I mean, if your stuff crashes, there's Python errors. You get stuff in the built-in logging facility. So.
Okay. Any more questions? And guys, you can ask Zulik in Lighting Talks room. I will say it.
How about the pricing? Like, if you wanted to set up a project as a toy project, check it out, is it like super cheap, or you? It's
basically free until you really get traffic. You get like 28 instance hours per day. So you can basically have one process running for free. You get a gigabyte. I mean, there's a bunch of free stuff there. So if you build something simple, it's free.
Okay, we have one question from Tomek regarding Tomek Modrzynski.
Okay.
You cannot move your app out of App Engine. There is the page appscal.com.
Yeah, I know. There's always like layers that offer the same API. It's always possible, but I don't know. I don't know how many people actually have success with that, but who knows? I mean, I would say it's a huge risk to invest. I mean, unless you really know.
Okay, he wrote it's not a question.
Okay. Thank you for that, Tomek.
Any more questions, guys? Watchers?
Okay.
Thank you.
Thank you.
Tomek?
Czy powinien wstać?
Tak,
Jak chcesz.
możesz.
Możesz i musisz.
Um,